Hello students, welcome back. I am Nikesa and today we are going to continue with the Ncert Textual exercise part 2 of chapter number 4, that is motion in a straight line. Okay, so let's start with the question number 9. 4.9. A cyclist starts from the center O of a circular park of radius 1 kilometer, reaches the edge P of the park, then cycles around the circumference and returns to the center line QO as shown in the figure. If the round trip takes 10 minutes, what is A, net displacement, B, average velocity, and C, average speed? Okay, so the cyclist starts from position O, moves to P, then circles here, okay, on the circumference till Q, and then again move back to O. Clear? Now see, first, initial position and final position are same. Okay, initial position and final position are same. So what is the net displacement? Zero. Okay, net displacement is equal to zero. B, average velocity. Okay, the formula for average velocity is equal to total displacement upon time. Okay, as the total displacement is 0 by t, that will be equal to 0 meter per second. Okay, because the displacement is 0. Clear? Now see average speed. So formula for speed is the total path length upon the total time. So path length, if I take path length, then that will be equal to distance OP plus arc PQ plus distance QO. That is the total path length covered. Okay. Now see the radius is 1 kilometer. That means OP equal to OQ is equal to 1. Okay. Now so OP equal to 1. Arc PQ. Okay, this is the 1/4 of the complete circle. So I write down 1/4 into the circumference, that is 2 pi r. What is r? 1. Plus what is OQ? 1. So it's 1 plus 1, 2 ones are 2 twos are. So it's 2 plus pi by 2. That is the total path length. Okay, so let's take the value of pi as 3.14. So it's 2 plus 3.14 divided by 2, that is 1.57. So the path length is 3.57 meter. Okay, now the total time. The total time is equal to 10 minutes equal to 10 upon 6. Sorry, it's kilometer. It's not meter, it's kilometer because the radius is given in 1 kilometer. Time 10 minutes, that means 10 by 60 hour, that will be equal to 1 by 6 hour. Okay, so I'm having path length, I'm having time, so the average speed, that will be equal to the total path length, that is 3.57 upon what time, that is 1 into 6 kilometers. So it's 3.57 into 6. So let's calculate 3.57 into 6. That is equal to 21.42. That is equal to 21.42 kilometer per hour. It's kilometer per hour. Okay, so this is the average speed. Okay, so this was about question number 4.9. A, it has the initial and final position are same, net displacement 0, as the net displacement is 0, average velocity is 0. And speed, I first found the path length, time, and then average speed equal to path length by time, and we got 21.42 kilometer per hour. Okay, so this was about question number 4.9. So just note it down. Now let's move to the next one, that is 4.10. Question 4.10. On an open ground, a motorcyclist follows a track that turns to his left by an angle of 60 degree after every 500 meter. Starting from the given turn, specify the displacement of the motorist at the third, sixth, and eighth turn. Okay, you have to calculate the displacement at third, sixth, and eighth turn. Compare the magnitude of the displacement with the total path length covered. Okay, magnitude of displacement with the total path length covered by the motorist in each case. Okay, so let's take that the motorist starts from this place. Let this be point E. Okay, and let it move in this direction. After 500 meter, let's say this point B, that is 500 meter. After that, it takes a turn left. So in this way, let this be 60 degree. Okay, so it takes a turn, again moves to 500 meter. Okay, then again takes the turn to the left of 60 degree. So let this be 60 degree. Okay, and again repeat, this is 500 meter. Again repeat this. Clear? So let me complete this figure. Okay, so this is the complete figure. Motorcyclists travel from A to B, take a 60-degree turn. From C to, again from C, B to C, he takes 60-degree turn on the left. After C to D, 60-degree turn on left, and so on. So the path followed by the motorcyclist is a regular hexagon with side 500 meters. Okay, now see the question. Specify the displacement of motorcycles at third, sixth, and eighth turn. Okay, so see, the first turn is at B, second is at C, and third is at D. Here there is the third turn. Okay, fourth turn is at E, fifth turn is at F, and sixth turn that is at A. Here there is sixth turn. Seventh at B and eighth at C. Here there is the eighth turn. Okay. Okay. So now you need to find out the displacement, and then you need to compare the magnitude of displacement with the total path length. So we'll find out both displacement and the path length at a time. Okay. So first at third turn. At third turn. Okay. What is the path length? This will be equal to AB plus BC plus CD. So that is equal to 500 plus 500 plus 500, and that is equal to 1500 meter. Okay. Now for displacement, I need to find out displacement means the shortest distance between the initial and final position. Okay, so this is the shortest distance between initial and final position. So I need to find out AD. Okay, now if I draw a line this way, let's say C and O. Okay, then see here, this is 500 meter, BC is 500 meter, that means AO will be 500 meter. Okay, clear? And if I take this triangle, okay, if I take triangle DOC, clear? then it will be an equilateral triangle. This angle will be 60, this will be 60, so this will be also 500 meter. Okay, so the total displacement will be equal to 500 plus 500, that will be equal to 1000 meter. Or else you might also use the logic that the length of a diagonal of a regular hexagonal is twice the length of the side. Okay, regular hexagon that is made up of 6 equilateral triangles. Okay, so remember the length of hexagon, regular hexagon diagonal, that is twice its length. So I can directly write down displacement is equal to 1000 meters. So this is at third turn. Okay, now let's take for sixth turn. So at sixth turn, it is again coming back at position A. Okay, now sixth turn. So at sixth turn, again it is coming at position A. So path length, that will be equal to AB plus BC plus CD plus DA, sorry, DE plus EF plus FA. So I can write down 6 times 500, right? 500 plus 500 plus 500, 6 times. So 6 into 500, and that is equal to 3000 meter. So at sixth turn, the path length is 3000 meter. Okay, and the displacement, you can clearly see that it came back to its original position. So the displacement is 0 meter. Okay, now let's see for the eighth term. Okay, the eighth term is complete rotation on the path of the hexagon, coming back to point A, then coming from A to B, and then C. So let's see for the eighth turn. Eighth turn. The path length will be first complete perimeter of the hexagon, that is 3000 meter, plus AB plus BC. So this will be equal to 3000 plus 500 plus 500. So that will be equal to 4000 meter. Okay, so this is the path length for the eighth turn. Now for displacement. Okay, displacement means this distance. Okay, if I take this as vector A, this means AB as vector A, BC as vector B, then this will be A plus B. So the magnitude of this displacement will be equal to, this is the magnitude of A plus B, and that is equal to under root of A square plus B square plus 2AB cos theta. Okay, if A plus B is the resultant vector of A and B, then the magnitude of A plus B will be equal to under root of A square plus B square plus 2AB cos theta, where theta is the angle between A and B. So if I extend this vector A and this as B, then the angle between them is 60. So this will be equal to magnitude of A. What is magnitude of A? 500. So 500 square. So it will be 25000 25 25000. Okay, plus B square plus B square. See the magnitude. Okay, the magnitude of B is also 500. So it will be again square plus 2 into A into B. A is 500, B is 500. Okay, into 2. So that will be equal to 5000 0 0. And cos theta. So what is cos theta here? Theta is 60. So the value of cos 60 is 1 upon 2, because cos theta equal to cos 60, and that is equal to 1 by 2. So 2 ones are, this will be again 2 phi. Okay, so this will be equal to square root of 7 phi 1 2 3 4 zeros. Now let's take the square root of it. 7 phi 0 0 0. It's 273.8. Okay, here there is a mistake. We just took 75,000. It's 7,50,000. So again, 7 5 1 2 3 4 square root. It's 866.02. So this is equal to 866.02 meter. So the displacement at the 8th turn, that is equal to 866.02 meter, and the path length is 4,000 meter. Okay. Now let's take the angle when it takes third turn. Okay, when it takes third turn, then this is the angle it is making with the original direction. Okay, so you can see here this angle and this angle both are 60 degrees, so this will be also 60 degrees. So I can say making angle 60 degrees with initial direction. Okay, so at third turn, the displacement is the path length is 1500 meter or 1.5 kilometer, and displacement is 1000 meter or 1 kilometer, and the direction is making angle 60 degree with the initial direction. Okay, for sixth turn, the path length is 3000 meter or 3 kilometer, and the displacement is 0, so it's at the same position, so we will not use the direction here. Okay, now for eighth turn, the path length we found out to be 4 kilometer. Okay, and the displacement 866.02 meter. Now for the direction, this is the direction. Okay, I will write down this as, this is the direction. Let's take this as angle beta. Okay, that it is making with a initial direction. Okay, so now you can use the formula. B means A and B are two vector, and the resultant vector is making angle beta with vector A. Then the formula is tan beta is equal to B sine theta upon A plus B cos theta, where theta is the angle between two vectors. Okay, so what is B here? 500. What is sine theta? Here angle between A and B is 60. So sine 60, its value is root 3 by 2 upon A, that is 500 plus 500. Cos 60, it is 1 by 2. Clear? So let us solve this. 500 into root 3 by 2. So let's take root 3 divided by 2 into 500. That is 433.012. And in denominator 500 plus 500 into 1 by 2. That is 250. So 750. So divided by 750. So that will be equal to 0.577. 73. Okay, now we used to take the trigonometric table for tan. So by using trigonometric triangle, the angle beta would be equal to 30 degree. Okay, but in this case you can also find it out easily. See, this is 500 500 500 and 500. Okay, AB 500, BC 500, CO 500, OA 500. So it's a rhombus. So the total angle is 60. So the diagonal will make angle half of it. So beta will be equal to 30 degree. Clear? Okay. So if I make a comparison between third, sixth and eighth turn, then let's form a table of that. Number of turn, path length and displacement. For third turn, the path length is 1.5 kilometer and the displacement is 1 kilometer and the angle is 60 degree with the original direction. For sixth turn, the path length is 3 kilometer and the displacement is 0 kilometer. And for the eighth turn, the path length is 4 kilometer. The displacement is 866.02 meter. And this is making an angle 30 degree with the initial direction. Okay. So this was about question number 4.10. Yeah. So just note it down. Now let's move to the next question, that is 4.11. 4.11. A passenger arriving in a new town wishes to go from the station to the hotel located 10 kilometers away on a straight road. See, it's a straight road from the station. Okay, so this it will be displacement because it is a straight road from hotel to station. A dishonest cabman takes him along a circuitous path of 23 kilometer. So 10 kilometer will be the displacement and 23 kilometer that will be the path length. Long and reaches the hotel in 28 minutes. The time taken is 28 minutes. What is A, the average speed, and B, the magnitude of average velocity? So I will write down here displacement equal to 10 kilometer and path length is equal to 23 kilometer. The time taken, that is equal to 28 minutes. That means 28 by 60 hours. Okay, so the first one, that is A, average speed. Average speed is equal to the total path length, that is 23, upon the time taken, that is 28 upon 60. Clear? So let's calculate this. 23 divided by 28 into 60, that is equal to 49.28 meter per second. And B, magnitude of average velocity, that is displacement upon time. What is displacement? 10 upon time, 28 into 60. So this will be equal to 10 into 60, that is 600, divided by 28. So that is 21.42. 21.42 meter per second. Okay. The next question, are they both equal? No. Average speed and average velocity are not equal. Okay. So this was about 4.11. So just note it down. Now let's move to the next question, that is 4.12. 4.12. Rain is falling vertically with a speed of 30 meter per second. A woman rides a bicycle with a speed of 10 meter per second in north to south direction. What is the direction in which she should hold her umbrella? Okay, now see, this will be the situation if the woman is stationary. Okay, the rain is falling in downward direction. Okay, and to protect herself, the umbrella must be in this direction, vertical direction. But now it is given that woman rides the bicycle with a speed of 10 meter per second. This velocity of rain is 30 meter per second downward. Okay, which direction? Downward. And the velocity of bicycle, okay, which a woman rides is 10 meter per second in the north to south direction. Okay, so let's consider this as south direction and this as north direction. So the woman is moving in this way. So now the woman must tilt her umbrella in the direction of relative velocity. Okay, relative in the direction of relative velocity of rain with respect to the women. Okay, so the relative velocity of rain with respect to the women, that will be equal to VR minus VW. Okay, now what is the direction of rain? VR, that is in downward direction. What is the direction of women? This woman is moving in this direction. Okay, with 10 meter per second. Now it's minus VW. I can write it down in this way: VR plus minus VW. So VW is in this direction, so minus VW opposite direction. This is VR. Okay, magnitude is 30. This is VW. I will say minus VW. Magnitude is 20. So this will be the direction of relative velocity of rain with respect to women. Okay, so the umbrella must be tilted in this direction. You can see here in the figure that umbrella is tilted by this angle theta with the vertical direction of rain. Okay, so we need to find out this angle theta. So this will be, sorry, it's 10, not 20. This is 10. Velocity of women is 10 and this is 30. So 10 theta, I will find it out. 10 theta, that will be equal to opposite, that is 10 upon adjacent 13, that is 1 by 3. So that will be equal to 1 divided by 3, 0.3333. I need to use the trigonometric table for 10 and find out the value of theta. So let's use it. So 0.3333, I will get here 0.3, it's 0.32, 0.33, 0.3327, 0.33. So this is the value which I got closer, 0.33, 18 degree 24 minute. Okay, if I want closer 27, I want plus 3, so it will be 33. So in mean difference I need to add 6, right? 0.3327 plus 0.0006 I will do. This will be equal to 0.33. So here the mean difference is 6. So 2. So 24 minute plus 2 minute, 26 minute, and degree 18 degree. So our answer is this will be equal to theta is equal to 18 degree 26 minute. Okay, so the woman must hold the umbrella towards the south. See, towards the, it is tilting towards south. Okay, woman who must hold the umbrella towards south at an angle 18 degree 26 minute with the vertical is the direction of falling ray. Okay, so this was about question number 4.12. So just note it down. Okay, students, so that's it for today. Thank you.